In this example, we're going to solve an exponential equation using logarithms. And as we can see in this example, we have 2 times 5 raised to the quantity 7x plus 3 equal to 8. As we look at this equation, there's a couple of things that we want to note. The first is that this variable x is in our exponent. So we'll need to use logarithms to solve it. And we know that because as we look at this left-hand side, we have a base of 5, that coefficient of 2, and on the right-hand side, we just have 8. So there'd be no way to kind of forgo the use of logarithms with this by just writing each side with the same base, as we've done in simpler examples. So we're going to have to use logarithms. And as we look at this, we could just apply the natural log function or the log base 10 function to each side, but that wouldn't be quite as efficient as we want to be. What we're going to want to do first is to look at isolating this part that contains our variable in the exponent. We're going to want to isolate this 5 raised to the 7x plus 3, and that'll make this problem the quickest to solve. So to do that, we'll take our original equation. And to do that, we're going to need to get this coefficient of 2 out of the way. So we'll divide each side by 2. And now we just have 5 raised to the 7x plus 3 equal to 4. So at this point, we have base 5 on the left side, and we've got this expression, which could be written with base 4 on the right side. So we'll want to either apply the natural log function or the log base 10 function. In this case, since we have a base of 5, it's not going to matter which one we use. If we had base 10, we would want to use log base 10. If we had an exponential expression with base e, we would want to use base e. But since we don't have either here, we can use either function. So I'll use the natural log function. So next, I'll then have that the natural log of this 5 to the 7x plus 3 is equal to the natural log of 4. Now, the logarithm property that I'll use, now that I have the natural log of this 5 raised to an exponent, that exponent 7x plus 3 can come out front. So now I'm going to have 7x plus 3 times the natural log of 5 on that left-hand side, and that's equal to then the natural log of 4. So at this point, it's important to note that this equation is just linear. So I will expand it and solve for x. So we'll get 7x times the natural log of 5 plus 3 times the natural log of 5, and that'll be equal to the natural log of 4. From here, we want every term containing x on one side, so we'll subtract out this expression 3 times the natural log of 5 from each side, and that'll leave us with 7x times the natural log of 5 equal to the natural log of 4 minus 3 times the natural log of 5, after we've subtracted 3 times the natural log of 5 from each side. As our last step, we can see that we have 7 times x times the natural log of 5, so we'll want to divide each side by that 7 times the natural log of 5. And we'll do that on each side again. And that is our last step. So we just have that x is then equal to the natural log of 4 minus 3 times the natural log of 5. That's in our numerator. And then in that denominator, we have 7 times the natural log of 5. As our last step, we'll state our solution set. And we'll just keep this in exact form. So we'll just put that exact solution in there. And so our solution set contains, again, that natural log of 4 minus 3 times the natural log of 5, all divided by 7 times the natural log of 5.